Welcome guys, welcome to the channel. I'm back and I have to apologize for not uploading that much in the past like 1 or 2 weeks, but I had a lot of things going on and pretty much it was really hard for me to manage everything. Never mind, I'm back and now we're talking about shellcode runner in C. We're gonna go through the whole process, explain the theory and so on. So without further ado, let's start explaining things and move into practical examples. Alright, so let me be straight and start with the theory and let's explain why I'm talking about C and not like for any easier and higher level language? Well, that's because C is really fundamental when it comes to operational system process and so on. It's a low level language, guys, so it can execute things easier. It has like easier support. For example, when you combine anything, it has automatically has a standalone portable executable PE, which you can reuse. The way of executing system commands is really easy. The way of interacting with Windows API is really easy, and you're gonna see that in just a moment. So that's why we're using C. And what about the shellcode? Why we need to run shellcode? Well, because in red teaming, usually we need to perform malicious coding. So code tools that do something. And often we're going to be doing pros injection, threat injection, pros howling. These are all techniques for obfuscating our activity and embed malicious instruction into some program. For example, Explorer, SVC host, Firefox, and so on. And we're going to build it from scratch. So we're going to start with a simple shellcode runner that runs shellcode into its own process. But then we can demonstrate in the future videos how it can be done for a remote process so we can hide ourselves. That's why I hope you enjoy and let's just start right into it and we're gonna explain everything as it goes on runtime. Alright guys, so let's start with my environment. I have command VM, which I honestly like when it comes to all kind of developing such software, all kind of shellcode runner, process injections, all kind of stuff. It really makes the things easier since it's like optimized for that. Of course you can build it with a usual like Windows box, but I prefer Commando. It works amazing with Visual Studio 2017. Now, here is my Commando and here is my Kali. Here we're gonna generate a shellcode and cache the listener. And now here, let me start the first C program, and I'm using that dev C++ ID, which is designed for C and C++. And it's really simple and fair to use. You just open it and click new and use source file, and you just start writing your code. Now the first thing I want to demonstrate is how the C structures and works. So pretty much in C we need to include all the libraries we need so we can execute functions from them. This is being done with hashtag and include. And then the library inside like a smaller and bigger sign. So for example stdio.h and then include windows.h. So all the C program must start with main method. So we need to define it int main and we put anything inside, for example, return 0. Now, when we save the file, we need to specify type C and do it like shellcode runner, SR, save it. Just take it some time. Sometimes it's not that fast, but it works. Don't worry about it. Now it's fine, and when I run the file, I should be able to see a return value of 0. That's because I specified it here. Now here I can pretty much start writing my code. For example, I need to print something, printf, and do like test. I want to execute system command. This is being done with system, and then the command dir, and I think that's about it. So if I run the program, we can see the keyword test and then the output of the system variable right there. Now if one of the beauties about C, if I minimize everything, we can see a standalone file with SR is being generated. So this is a portable executable, meaning it does not require any kind of DLLs to it, any kind of like metadata embedded to it. Everything's inside and it can be easily transferred. So if you're developing something targeted Windows, just compile it in C and it should work. That's it. You don't need to transfer anything else. If I run the file, you see a flash PowerShell or CMD screen there, and that's because the program finished executing like immediately. So before that happen, I can do like define a new variable, for example, in stopper equals to 0, and here type scanf %d and to stopper. That way we're gonna halt the execution of the program, and now when I run that, we can see the same thing, test the things of the dir, the output of the dir, but now the program needs me to write something, and after that it exits. So here, if I were to open DSR again, we can see it does the same thing. So that's about it. Now, this is the really basic structure of the C program. You can, of course, define functions outside of main, and there's the good practice of splitting everything into multiple functions, and each function must do only one thing. This is the good practice for programming language. But now we're not gonna dive into anything that complex, but we're gonna create a shellcode runner using C. Now, the next beauty of C that I want to mention is that since it's low-level language, it's extremely easy to work with internal calls, for example, Windows APIs. Now, in .NET, you need to define a bunch of DLLs. You need to define each method of that DLL with the correct signature, which you need to look for p-invoke.net, and then you need to use that method then. But in C, all you have to do is include windows.h. That's it. Now you have access to all Windows APIs, and you can just execute them with the snap of your finger. So let's go and generate our shellcode. Let's go to command to P.S Sorry, and do msvenom p windows x64 shell reverse TCP lhost eth0 and lport 443 format C. Let me explain what that is. So we have msvenom, we have the payload of Windows platform. Then we're gonna define a 64-bit of architecture of the payload. Now, when it comes to shellcode, AV bypasses, things like that, we always need to stick to 64-bit as much as possible, because the 64-bit is compatible with 32-bit. So 64-bit operational system can run 32-bit process, but 32-bit operational system cannot run 64-bit process. So that's why a lot of viruses and malwares and malicious software were developed having 32-bit architecture, because to be compatible to everything. But nowadays, every operational system is being 64-bit, and the DDRs are not that optimized for 64-bit process and executables. So there are rare chances when your PE, portable executable, can pretty much bypass antiviruses based on their architecture. So the golden rule is that we have to stick a 64-bit process as much as we can. Now, that's it. Then we define the stageless payload. So the full payload is gonna be that body you see right here, and ignore the errors. It's been for my Ruby version, I believe. Not sure, I need to fix that, but that does not produce any kind of critical errors that can stop our progress. Never mind. So the shell reverse TCP, that payload is stageless, so everything's inside, and it's a larger payload. For example, you can see the final size of a C file is being 2 megabytes almost, or kilobytes. Yeah, kilobytes, not sure. So 2000 bytes. Then we specify the IP of the callback, the port, and format C, since we're writing and want to embed that into the C. Now, of course, if we were to make anything practical, we will not use msvenom at all, or use some kind of stagers, encoders, encryptors, and so on. But for simple use, we use stagers payloads. We're gonna cache it with netcat, and the payload is that one right here. So I'm gonna copy it. Then I'm gonna set up an netcat listener and ncmvop443, and now let's move on to commando. Now here we can specify variable with several sections. We can specify variable here, which makes it global. So of course, when it's global, each method can access it. We can specify inside the main or inside any other function, but for simplicity, we're gonna use global variables, right? Just like that. Now I need to mention that there is a really important factor when you decide where to store your variables, and that's the factor of where that shellcode will be displayed if the portable executable will be analyzed. So there's the tools like PE Studio, which can analyze different headers or portions of your portable executable, PE. That means you have I think 4, 5 of them, and you can create the custom ones. So every PE has headers, has data, and so on and so on and so on. And if you store a variable to be global, it's being stored in one of these sections, I believe in header. And if you store that buffer here, if you store it into a method, then it's stored into different sections of the portable executable. So that's a really important factor. All right, now since we defined the character buffer, we're gonna call it shellcode for simplicity, of course. And then we need to include, or to invoke, actually, apologize, the Windows APIs we want to work with. We have 2 APIs. First one is being virtual alloc, which pretty much allocates memory in our process context. So imagine each process has its own context of memory and threads, and we can allocate memory inside of that context. That's why VirtualWalk is being used. So the syntax is, we can see it's using C++, but the function's parameter signature is kind of the same for every language. So we have VirtualWalk, which has one optional argument, which is being LP address. When we set that to 0, the program and memory management, the Windows itself is gonna automatically assign the start address of the memory, or we can do it manually. Then we have the size of our shellcode. Then we have FL allocation type and memory protection registers. So we have two types of registers, of options, let's say. That's gonna be the mem commit, and that's gonna be page execute read write. All right. So let's go ahead and write that thing real quick. Let me just go here, remove everything, and type void, and then pointer to exec. Let's just call it exec. That way we create a pointer, and that pointer is gonna equal to VirtualWalk, and then specify, as I said, 0, so the system automatically knows where to start the memory allocation. Then we need the size of shellcode that automatically is gonna read the shellcode, determine its size, and return it back. Then, as I said, we're gonna need mem commit, and then page execute read write. That's the first API. And if you see how we call that API in C#, you can say, whoa, that's really simple here. And if you just hold Control and click any of the APIs, you can see its signature. So as I said, it's slightly the same. We have LP address, size, allocation type, and memory protection, FL protect. So these are all flags, the third argument and the fourth argument. So let's close that. And then we're gonna need to copy the content of the shellcode variable into the memory we just allocated. And that's being done with a function called memcpy, memcopy. Then we need to specify the pointer exec. Then we need to specify the shellcode, which is being shellcode. And then we need to specify again the size, so size of and shellcode. All right, that's about it. Now the only thing we need to do is to execute that portion of the memory, because so far we just allocated memory, we wrote our shellcode there, but we need to wait for us executing actually that memory there. Usually that's been done with an API called create remote thread, but now since we're using C, the syntax is slightly different, and it's like void star like that, exec, and finish the syntax like that. I know it's kind of strange, but you have to memorize it or write it somewhere so you have a note for it. That way we force the execution of the memory we just wrote there. And then that return 0 is not making any bad. So let's just run the program and see what happened. The listener is being on. I'm gonna compile and run the program, and the terminal window hangs. That's a nice sign, because when the terminal is idle, we know something is going on. So we don't have error, we don't have anything going on there. But if we go to the listener, we can see we have a callback. And now if I do who am I, we can see we have a code execution. Now we achieved remote code execution, but I want to explain a few more things and then try to upload that file to antiscanme to see how much AV vendors are catching that. Why do we need to, you may ask, why do we need to write shellcode or embed shellcode when we can pretty much write code, malicious code itself, for example, reverse shell, opening socket, and so on? Well, when it comes to red teaming, we usually need to come facing cross injection, cross migration, and problems like that. And when you have such problems and you need to stay as much invisible as possible, you need to operate from memory. And the way to operate from memory is to inject your shellcode there, because the memory is using machine instructions, and the shellcode you see is nothing much but hexadecimal representations of the machine instruction themselves. So what these machine's instructions are doing is they're pretty much forcing the command output, command input, and command error back to the listener. That's it. That's all the reverse shell is. So whenever we have some kind of a problems like cross injection and we need to operate from memory, if you, for example, develop your own piece of code and if it somehow bypasses the AV, when you start, you're gonna see a process running with that name and generating traffic. But we want to make a shellcode like a malicious program and then embed it into process like SVC host, which is initially making memory network requests, and that way we are being like more invisible and harder to catch. So that being said, I want to pretty much rename that to buff, and then I want to rename that to buff again because shellcode is catchy, and buff again. I think that's it. I'm gonna compile now and upload to antiscanme. Now keep in mind that since we're using generic shellcode generated from msvenom, the chances of us getting caught are high, and I suspect at least the half of the AV is gonna caught us. But let's just see. Come on. Yeah, so as I said, 60 out of 26, even more of the half, are saying that's a virus, and that's because we're using a non-signature made from msvenom, but that's for more for next videos, because generating like a personal shellcode is not an easy task, and we need to cover a lot of things, so we're gonna stick to that later. That was it, guys. That was it, how to run a shellcode with simple C program. And I hope you enjoyed and learned something new. If that's the case, make sure to like the video, comment, share, and subscribe to the channel. I really appreciate every single one of you. So that was from me today, and I'll see you again in the next one.